Hi students, welcome to this video. Now in this video, we are going to discuss NEET physics. So in NEET physics today, the topic we are going to discuss is atom models. So already we know some of the basic concepts about atomic structure and atom model. The Thomson's atom model, Rutherford atom model, Bohr atom model and Sommerfeld atom model. So like this, so many atom models are there. The initially, if we see Thomson atom model, this atom model has lot of drawbacks. Therefore, it is not followed. Then next comes the Rutherford atom model. Rutherford atom model paved the way for the discovery of nucleus. So Rutherford alpha scattering experiment only explained most of the positive charges are concentrated only at the center. The center is called nucleus. Okay, so the Rutherford atom model explain nucleus. At the same time, all the electrons are revolving around the nucleus in circular orbit. Okay, but the fine structure, the line spectrum, these concepts are not explained by Rutherford atom model. So some of the drawbacks Rutherford atom model had. So due to these drawbacks, Bohr atom model is introduced in order to overcome the limitations of the Rutherford atom model in explaining the stability of the atom and the line spectra observed for hydrogen atoms. Niels Bohr introduced his model. That model is called Bohr atom model. He was the first person to give better theoretical model of the structure of the atom to explain the line spectrum of hydrogen. So first of all, we will see the postulates of Bohr atom model. So according to the postulate, so there are two postulates. The first postulate, let us see now. According to the first postulate, the electron in an atom moves around the nucleus in circular orbit under the influence of Coulomb electrostatic force of attraction. This Coulomb force gives only the necessary centripetal force for the electron to undergo circular motion. So the electrons are revolving around the nucleus only by Coulomb force. Okay, then next one, the B point. The electrons in an atom revolve around the nucleus only in certain discrete orbits called a stationary orbit, where it does not radiate electromagnetic energy. But in Rutherford atom model, according to Rutherford, electrons revolving in orbit, they radiate energy. So if electrons radiate energy, immediately the electrons lose their energy and finally fall into the nucleus. This is a drawback. But in Bohr atom model, stationary orbit are discussed now. So the electrons revolving in stationary orbit does not radiate energy. These orbits are called stable orbits. So the angular momentum of the electron in the stable orbits are quantized. Okay, so according to the formula, L is equal to NH cross, right? So H cross is equal to H divided by 2 pi, where H is called the Planck's constant, right? So here L is the angular momentum of the electron, right? So the angular momentum of the electron is quantized in the stable orbit. Therefore, the first condition of Bohr atom model is called angular momentum quantization condition. This is Bohr atom model's first postulate. Okay, whether this first postulate is correct or not, this is discussed according to de Broglie's concept. So already we studied, de Broglie only explained the theory of matter waves. Okay, so electrons when revolving around the nucleus in circular orbit, the electrons exhibit the wave nature. The standing wave pattern for the electron in stable orbit is given in the diagram. If the orbit is 3, that means principal quantum number is n is equal to 3 means then the electron is said to have 3 waves. That is given in the diagram. Okay, right? If the principal quantum number n is equal to 5 means then the electron is said to have the standing wave pattern, 5 waves are there. Right? So, for the circular orbit, the circumference is 2 pi r. So, the circumference of the electron's orbit of radius r must be an integral multiple of the de Broglie wavelength. Therefore, 2 pi r is equal to n lambda. Okay. Therefore, lambda is equal to h divided by mb. This is according to de Broglie wavelength equation. Right, here m represents the mass of the electron, v represents the velocity of the electron, lambda de Broglie wavelength. So 2 pi r is equal to n lambda. This is de Broglie equation. So for lambda, substitute h divided by mb. Therefore 2 pi r is equal to n into h divided by mv. Rearrange this. If we rearrange this one, then we get mbr is equal to nh divided by 2 pi. So this is given in the script as marked 1. mbr is equal to nh divided by 2 pi. But mbr is nothing but the angular momentum of the electron. Okay, so mbr is equal to L. Therefore mbr is equal to L is equal to nh cross. Okay, therefore Bohr's concept matched with the de Broglie concept. So in this way, Bohr's first postulate is verified. Okay, now we will see Bohr's second postulate. So Bohr's second postulate is otherwise called frequency condition. So at what condition the electrons will emit or radiate energy? right? So energy of orbits are not continuous but discrete. So this is called quantization of energy. An electron can jump from one orbit to another orbit by absorbing or emitting a photon whose energy is equal to the difference in energy del E between the two orbital levels. That is, del E is equal to E final minus E initial. Right? So while the electron, while revolving in stable orbits, does not radiate energy, but electrons radiate energy when it jumps from an orbit of higher energy to an orbit of lower energy. That is what given here. Therefore, the difference in energy is del E. So del E is equal to E final minus E initial. This is equal to h nu. Right? Here h is called the Planck's constant. Nu represents the frequency of the radiation. So instead of that nu, we write by c by lambda. Okay, so where c is the speed of light, lambda is the wavelength of the radiation used. Nu is the frequency of the radiation. Thus, the frequency of the radiation emitted is related only to change in atoms' energy, and it does not depend on the frequency of electrons' orbital motion. That is called Bohr's second postulate. Okay, so already we discussed Bohr's first postulate. So this one is the Bohr's second postulate. So in the next video, we will discuss the energy levels of Bohr's atom model and the limitations of the Bohr atom model. So you observe this video, like this video and share this video and subscribe my channel also. Thank you.